All right, a silvery blue-green color of the Colorado spruce makes it a perfect Christmas tree. I have one of these. For a tree farmer in Indiana, when a seedling is planted at time t equals 0, the height of the tree is 1 foot. So I'm going to write that down. Times 0 is 1 foot. I'm going to need that later. If the height of the tree in feet at time t years after it's planted, the rate of growth is proportional. There's a word that we saw earlier. The rate of growth is proportional to the difference between the maximum height, 10 feet, and its current height. Oh, and they even gave it to me. I thought we were going to have to come up with this, but we don't. All right, so there is my rate of growth right there. Okay. Is the tree growing faster when it's 2 feet high or when it's 4 feet high? Explain your reasoning. How am I going to know? Plug them in. See what it is. So I know that I'm looking for dH dt. I want to know what the rate of growth is when h is 2 feet. So that's going to be 3/20 times 10 minus 2. So that's going to be 24/20. Now, anybody know what this is? 24/20 is what? What's the rate of that? Anybody tell me from what it says? You can simplify it if you want. What is that? What is that dH dt standing for?
Feet per year.
Feet per year. Did I start the video? Yes, okay. So this is feet per year. Then we want to find out what's the rate that the height of the tree is changing when h is 4. So that's going to be 3/20 times 10 minus 4, which is going to be 6 times 3, which is 18/20 feet per year. So can anybody tell me what is which time is it growing faster? 24 over 20 greater than 18 over 20? So you would say the tree is growing faster at at h equals 2 feet. So the tree is growing faster and h equals 2 feet because dH dt when h equals 2 is greater than dH dt when h equals 4. There you go. First part. Second part says, find this. What's d to the second power h over dt to the second power mean? What's that stand for?
Second derivative.
What? Second derivative. So guess what I got to do with this function? dH dt that they gave me was 3/20 times 10 minus h. Anybody know what I got to do with that?
Distribute.
What do I got to do with this? To get this? Right. I got to do the derivative. So the derivative of this with respect to dt means I got to do, and this is a constant in front, so I'm going to put the dt down here. Okay, so use this expression to explain why the graph of the curve is concave down. All right, so, I put t on that. It's dH dt. So we're doing the derivative. This means you're doing the derivative of h, the derivative of the function with respect to t. So what do I get here? Well, this right here is the d2h dt squared. Over here, the 3/20 stays in front. What's the derivative of 10? What's the derivative of negative h? Now, anybody know what this is in terms of? This was feet per year. What's the second derivative in terms of? Feet per year. Okay, so then it says, use this expression to explain why the graph of the solution is concave down. The graph is concave down. Why? Why? The second derivative is less than 0 in the entire domain or function. Over the entire function, over the entire domain, however you want to say it, it's negative 3/20 the entire time. So that's concave down. If the second derivative is negative, concave down. If it's positive, if the second derivative is positive, concave up. Find the equation of a tangent line. What do you need to know to get the equation of a tangent line? What do we need? Point and slope. It's the same from that first week of school. To the graph of h at the point 0, 1, so they're giving me the point. No, that's not 1. At t equals 0, my bad. Use the tangent line to approximate the height of the tree at 1 year. Is the estimate an over or underestimate? All right, so here we go. All right, so we need to do what? What do we got to find out? Anybody know? What two things do we need? Point and slope. All they gave me was a times 0. What did they tell me up here in the problem? At times 0, what was my tree? So at times 0, the tree is 1 foot. Now, how am I going to get the slope when time is 0? How do you get the slope when the time is 0? Plug it into what? And you take your dh dt, because that's the slope, and you're going to plug 3/20 times 10 minus 0 in. So that's going to be, let's see, that 10 and that 20 will reduce to a 2.
Wouldn't it
Yep.
be 1 because it says the height is 1 foot?
Oh, say what now? Oh, you're right, it should be a 1. My bad. You're right, 1. H is 1. So that goes back to 20, and that stays 10. So we got 9 times 3, 27/20 is our slope. So what's my tangent line? Y minus 1 is going to equal 27/20 times x minus 0. There's your tangent line. Says approximate the height when t is 1. And I put x and y in there. They will not count that wrong. Does anybody know what the y is supposed to be? This is h of t, and this x should be t. So we're going to take and we're going to plug a 1 in right there. So h minus 1 is going to equal 27/20 times 1, which is going to be 1 plus that. So that's going to give me that h of 1 is going to equal, let's see, if I add 20/20 to that, that's what, 47/20? Okay, so the tree is going to be 47/20 feet tall. If you want to write that as 2 and 7/20 feet, you can. Okay, so there's the height of the tree. Now, it wants to know, is this an over or underestimate? Well, what do we know about this tree growth? What did we find out here, and what do we know about a tree growing? Anybody know what the graph would look like? Anybody got any ideas? Let's just take a picture of what the graph looks like. Times the, you got the graph. At time 0, the tree is 1 foot high, right? At time t equals 1, the tree is 2 something, right? 2 and 7, whatever. Now, what do we know about this graph? The tree's going to keep doing what? Growing, so the height's going to keep going up. And what did we find out in part B? Concave down. So what that means is the tree is going to be doing something like that. Or thumbs up what that's telling me. Now, we found, didn't we find a tangent at this point? So if I come over here and I draw the tangent at that point, if I'm not mistaken, The tangent line would be something like that. So our prediction, actually, I'm sorry, I did the wrong tangent line. It said zeros when we did it, 0, 1. So this is my tangent line right here. We predicted using the tangent line, didn't we? And we predict what this point would be. You know, we're going to get something like up there on the tangent line, aren't we? It's that. No, I kind of lied to you because this is the actual tangent line right here. So this graph is actually lower. But anyway, you get the idea that the tangent line is here, and this is down below it. So is our we use this line to predict it. Is that an over or underestimate? It's higher, isn't it? So we would say this is an overestimate. Because D, T, DH, H, T upside down again. DTH to DT squared is less than 0. Because the concave down, whatever concavity is going to make it go slower up than the line. Does that make sense? Now, if this would have said concave up, if you would have had concave up here, and it goes like this, then your prediction would have been an underestimate. Do you see why? So the concavity is what you use for the reasoning. I would probably put over the entire domain or something like that. Okay, so there you go. We thumbs up on that. So you're going to use your second derivative to tell over and under estimates. All right, next problem says, find a particle solution to this differential equation, h of 0. Find, a particular solution to this function. Okay, we have not done the integral yet, huh? So that's what we got to do now. All right, so we're going to do the integral. Well, take that back. Let's rewrite the equation down. We got dH dt is going to equal, where is it? 3/20 times 10 minus h. Now, what do you got to do? What? Okay, before we integrate, what do we got to do?
Separate.
We have to separate. We got to separate. What side should the h's go on? Left side, because the dh is on top. The t should be on the right. Do we all see that this has an h with it right here? So I got to get that to the other side. So I'm going to have 1 over 10 minus h dh is going to equal 3/20 dt. Now I'm going to integrate both sides. Now because there's a negative there, I am going to use u substitution. I'm going to say u is going to equal 10 minus h. So du is going to equal negative dh. So what do I got to create? I need a negative dh. Do I have a negative dh? What do I got to create?
A negative.
Got to create a negative and destroy a negative. So that's going to give me negative 1 over u du is going to equal 3/20. What's the integral of 1? Okay, so this is going to give me a negative natural log of u is going to equal 3/20 t plus c, and I'm going to get rid of the negative sign, so I'm going to multiply each side by -1, and then I'm also going to stick in my 10 minus h back in here. Now, this is actually a negative c here, but I'm just going to leave it plus c. If you put a minus c there, it's okay, but you'll have to leave it minus. This c right here is different than that c. They are not the same. Some people put a little subscript 1 there and subscript there 2 to tell you they're different. You don't have to, but they are different. And now I got to get rid of natural log, so I'm going to get e on this side and e on this side. So over here, I'm gonna have 10 minus h is going to equal, let's see, we would get, okay, I'm gonna tell you again that this is times e to that c right there. So this right here is a brand new c that I'm gonna stick here in front. We got that deal. And now what I do when I get to this point is when I plug in the point I have. So we're going to use the point 0, 1. So that's going to be 10 minus 1 is going to equal CE to the 0 power. So C is going to be 9. So I'm going to have 10 minus H is going to equal 9E to the negative 3/20th T power. And whenever you plug the number in, you got to plug that back into wherever you plug the number into, this line, not somewhere else. So there's my equation. I'm going to go ahead and solve this. Okay, yes. I'm going to solve this for h. I'm going to subtract 10 over. And I'm going to multiply by -1 or divide by -1. Which changes both signs on the other side. So right there is my function. And we probably should write this h of t. Question on that one? All right. Now, what does part E say to do?
If a tree is harvested when its height is 8 feet, at what time will a blue spruce be ready to sell?
So basically, when h is 8, what's t? Right?
Yeah.
Yes, sir. You got a question?
Well, you gotta spray.
Huh?
You gotta spray. Spray the best.
Okay. So I get 8 equals 10 minus 9e to the negative 3/20th t. So then I gotta subtract the 10 over, so I get -2 equals negative 9e to the negative 3/20th t. And I gotta divide by negative 9. I get 2 9s equals e to the negative 3/20th t. And I got a natural log each side to get rid of the e. So I get negative 3/20th t. And last, I gotta multiply by the reciprocal, negative 20 over 3 times the natural log of 2 9ths. So whatever that is, round to 3 places, and that's your